This question is the mechanics component of the applied maths paper, Edexcel June 2024. Question 4. The question says, at time t seconds, where t is bigger than 1, the position vector of a particle p is r meters, where r is equals to c times t raised to the power half I minus 3 over 8 t squared j, and c is a constant. When t is 4, the bearing of p from O is 135 degrees. A. Show that c is equal to 3. B. Find the speed of p when t is equal to 4. When lowercase t is equal to uppercase t, p is accelerating in the direction of minus I minus 27j. Find the value of uppercase t. So we know that r is equals to c t raised to the power half I minus 3 over 8 t squared j. When t is equals to 4, r is equals to 2c, because 4 raised to the power half is the square root of 4, which is 2. So I have 2ci minus 3 over 8 times 4 squared, which is 16j. This will reduce to 2ci minus 6j. So this is the position vector of p when t is equals to 4. But we are told that for this case, the bearing is 135. So let's try to sketch it. So I have cardinal points over here. So that will be enough. And the direction according to the bearing will be somewhere over there, which means this angle here is 135, as bearings are always measured from the north. But we know that this angle is 90, which makes this angle here 45. So the components of the vector, which will be this line here, and that means that this component of the vector is 2c. So that's 2c, and this component will be minus 6. So I put in 6. The direction is already going down, so we just put in 6. Now, this angle here is 90, which makes this angle 45 as well, which means that this length over here and this length over here are equal. That means 2c is equals to 6, which implies that c is equals to 3 as required. So that's A. Now for B, find the speed of p when t is 4. We will need to differentiate r to get the velocity. So the velocity v is equals to dr dt. Now if I differentiate that, I'm going to get 3 over 2 t to the power minus a half. So I have just differentiated this one here. So that will be minus 3 over 8 times 2 t. And this is the I component and the j component. So simplifying that, I'll get 3 over 2 t to the power minus a half minus 3 over 4 t j, and I over here. Because 2 cancel here, 1 and 2 cancel there, 4. So this is the velocity vector. I'm now going to write this vector as follows. So v is equals to 3 over 2t to the power half I minus 3 over 4 tj. But we have told to find the speed of p when t is 4. So when t equals to 4, v equals to 3 over 4I minus 3j. Because when I put 4 here, I'll get the square root of 4, and the square root of 4 is 2. 2 times this 2 is 4. And when I put 4 here, I'm going to get 3, because the 4 will cancel the 4. So the velocity when t is 4 is this one here. Now we are told to find the speed. So the speed is equals to the magnitude of the velocity, which is equals to the square root of 3 over 4 squared plus minus 3 squared. That will give square root of 9 over 16 plus 9. This will be the same as square root of 9 brackets 1 over 16 plus 1. And that will give me 3 root 17 over 4. If you evaluate that, you're going to get 3.09 meters per second. That's 3 SF. For 2 SF, you're going to get 3.1 meters per second. And that is the solution for part B of the question. Now for C. C says, when lowercase t equals to uppercase t, p is accelerating in the direction minus I minus 27j. Find the value of t. So we already know that v is equals to 3 over 2t to the power minus a half I minus 3 over 4 tj. Now for acceleration, we need to differentiate the velocity. So for acceleration, I'm going to get dv dt. And if I differentiate, I'm going to get minus 3 over 4 t to the power minus 3 on 2 I minus 3 over 4 j. But we want the acceleration when lowercase t is equals to uppercase t. So when t is equals to uppercase t, I will have a equals to minus 3 over 4 t to the power minus 3 on 2 I minus 3 over 4 j. But we are told that in that case, the acceleration is in the direction of minus I minus 27j. This means that this vector is a scalar multiple of this vector. So that means that minus 3 over 4 t to the power minus 3 over 2I minus 3 over 4 j is equal to some scalar constant k times minus I minus 27j. I'm now going to multiply each term of this equation by minus 1. So if I do that, I am going to get 3 over 4 t to the power minus 3 over 2I plus 3 over 4 j equals to ki plus 27 kj. Now if you compare both sides of the equation, we can see that 3 over 4 t to the power minus 3 over 2 is equals to k, and 3 over 4 is equals to 27k. Now if I divide this by that, I'm going to get k over 27k. So let's do that. So I have 3 over 4 t to the power minus 3 over 2 divided by 3 over 4, which is this one here. That must be equal to k over 27k. And now you can see that this will cancel that, and then k will cancel k. So this implies that I have t to the power minus 3 over 2 is equal to 1 over 27. I'm now going to find the reciprocal of both sides of the equation. So if I do that, the reciprocal of that will be t to the power 3 over 2. And the reciprocal of this one will be 27. This can be written as t to the power half all cubed is equals to 3 cubed, because 27 is 3 cubed. And because the powers are the same, I can say that t to the power half is equals to 3. To find t, I'm going to square both sides of the equation. If I square both sides, the left-hand side becomes t, and the right-hand side becomes 9, because j squared is 9. And so the value of t required is 9. And this is the solution to part C of the question. Thank you for watching. See you in the next video.